All right, welcome back. So today we are going to be talking about how to solve for a variable. And previously to this, we have been solving for one variable, right? If we have an equation such as x plus 2 is equal to 5, we know we use inverse operations to isolate our variable. Therefore, we get that x is 3. So far we have been working with equations that deal with one variable. Today we're going to be talking about equations that deal with multiple variables, or sometimes only variables. You might also hear this referred to as manipulating equations, because that's really what we're doing. Here we're not necessarily going to be solving for values, we're going to be moving around terms within our equation or within a formula to isolate one specific variable. So without further ado, let's begin. So solving for a variable in a formula can make it easier to use that formula. And you're going to see this a lot in science, or you might have already seen it in science. The process is similar to that of solving multi-step equations. We're going to find the operations being performed on the variable that you're solving for, and then use the inverse operations. Just like before, in this very quick example, we saw the variable was x and it was getting acted upon by adding 2. So we subtracted 2. We use the inverse operation. We're going to continue that general process, but now we're not going to be getting specific values. We're sometimes just going to be manipulating or rearranging certain terms within our formula. So let's say we're talking about the equation or the formula A is equal to LW. Really, this is the area formula for a parallelogram, right? We have the area is equal to the length times the width, and we're trying to solve for W. We want to notice what is currently getting operated upon the variable we want to isolate, right? So we want to isolate, come on now, there we go. We want to isolate the W. So we see that W is getting multiplied by L. So in order to solve for W, we'd have to divide both sides by L. In this perimeter formula, we have P is equal to 2L plus 2W. And again, we want to solve for L. The first thing that we notice is L is getting multiplied by 2. That is the first operation upon it. And then 2L is being added. So adding 2L happens secondary. So we're going to do the inverse operations. Since 2L is getting added, we're going to subtract 2L, or sometimes you hear referred to adding negative 2L, but we can also just say it's getting subtracted on both sides. And now we have W is currently getting multiplied by 2, so we have to divide both sides by 2. And you're going to see that the order of inverse operations is the order of operations in reverse, right? It's the opposite. Inverse operations are the opposite operations. So we do it backwards, just like we would solving equations. So let's put it into an actual scenario. Let's put it into an actual example. The formula A equals 1/2 B times H relates the area A of a triangle to its base B and height H. We want to solve the formula for B. So we want to get that B isolated. So we have to first identify what is happening right now. Well, B is getting multiplied by 1/2. So what we're going to do is we're going to multiply both sides by the reciprocal. We're going to multiply both sides by 2 over 1. What we do to one side, we do to the other side. So we multiply everything by 2 over 1. Therefore, we get 2A is equal to B times H. Now we notice, okay, well, hey, B right now is not isolated. It still has another variable with it. So it has something else there. B is currently getting multiplied by H. So we think to ourselves, okay, if it's currently getting multiplied by H, we have to divide both sides by H. And therefore, we get that B is now isolated, but it's equal to 2A over H. Notice here, we didn't get rid of a variable, we didn't get rid of a value, we just manipulated the formula a little bit, which means now if you are trying to figure out the base of a triangle, but you know the area and you know the height, you're going to be able to figure out the base because you have those given values to solve for your unknown. Awesome. with this, please work on problems 1 through 5 on the guided notes and resume when you're ready to move forward. All right, so any equation with 2 or more variables can be solved for any given variable, right? We saw that last example. We had A, B, and H, and we solved for B. So in this equation, we have x is equal to y minus z over 10. We want to solve for y. So we want to get that y isolated. Well, the first thing that I notice is that y minus z is getting divided by 10. So we have to use our inverse operation. So we multiply both sides by 10 because we want to get that y all by itself. In doing so, we have 10x is equal to y minus z, which means that z is subtracted from y, and we want to get that y all by itself. In order for us to do that, we're going to have to add z to both sides. So we get 10x plus z is equal to y. And notice, all the same variables are there. There's still an x, there's still a y, there's still a z, and there still has some kind of value of 10. So we didn't change anything too much. We just manipulated the equation, we rearranged the formula, and we were able to isolate for y using inverse operations just like we normally would when it comes to equations. Awesome. Let's go over one more example. Let's say we have this equation here. A is equal to b plus c divided by d. We want to solve for c, which means we want to get c all by itself. Well, the first thing that we might notice is that we have b getting added to c over d. Since we have b getting added to c over d, we want to isolate that c, but we have to subtract b on both sides. Just like if it was a number, we want to move our subtraction and addition first and then worry about multiplication and division. So we subtract b from both sides. Again, you sometimes will hear it referred to as adding negative b. I like to say subtract b because we're using the inverse operation. So we get that a minus b is equal to c over d. Now, a and b are not like terms, so we cannot subtract them, so we just write it out as saying a minus b. Whatever those values are, when we eventually find them, we can plug them in or substitute them in and finalize our answer. But c is not yet isolated. C is currently getting divided by d, so we use inverse operations, so we multiply by d on both sides. In doing so, our c is going to be isolated. We have d times a minus b, dab on it, is equal to c. And then that's it, right? We could use the distributive property to get dA minus dB is equal to C. But right now, this is totally fine because then it's a little bit more work if we distribute because we don't know the value of D, nor do we know the values of A or B. So if we leave it as this setup, we're going to be A-OK. Awesome job with this, folks. Please work on problems 6 through 11 on the guided notes. Please let me know if you have any questions. You're working really hard. You should be proud of yourself. Keep up the good work. I'll talk to you soon. Thanks.